Here's a classic question you'll hear in almost every data science interview. What's the difference between a population and a sample? In statistics, a population refers to the entire group you want to study, every possible data point that exists. Think of it like all the customers in a company's database, or every transaction ever made. A sample, on the other hand, is a smaller subset that represents that population. In practice, we rarely have the resources or time to analyze the full population, so we work with a sample to estimate the same insights. Population means the complete data universe. Sample means a smaller, measurable version that stands in for it. This concept tests three things in an interview: your grasp of statistical inference, your understanding of sampling methods, and your awareness of bias. The key challenge is ensuring that the sample truly represents the population. That's why we use techniques like random selection, stratified sampling, or systematic sampling. Each method tries to minimize bias so our conclusions are trustworthy. The visual here shows exactly that: the large red sphere representing the population and the smaller connected one showing the sample drawn from it. In short, population gives us the truth we want to know. A good sample helps us get close to that truth efficiently. Now, let's translate this idea into Python. Using the NumPy library, we can simulate both the population and a sample. We start by generating a large dataset using NumPy's random normal function. For example, 100,000 data points centered around a mean of 100 with a spread of 15. This simulates our population. Then, we draw a smaller subset using NumPy's random choice function, say 1,000 observations, to represent the sample. Once we have both, we compute summary statistics. The population's mean represents the true average. The sample's mean gives us an estimate of that average, and the standard error, which we calculate by dividing the sample's standard deviation by the square root of its size, tells us how close that estimate is likely to be to the population value. Now, this short script brings statistical inference to life, using a small sample to make reliable statements about a much larger population. In real-world analytics, that's exactly what happens. For instance, clinical trials test medicines on about 5,000 participants to predict how the drug will perform for millions. The same principle guides survey analysis, A/B testing, and model validation. Every time you train a machine learning model, you're relying on a sample of data to infer performance on the entire population. So if you get this question in an interview, you can confidently say, a population represents the full dataset, while a sample is a subset used to infer its characteristics. In Python, we can simulate both using NumPy's random normal and random choice functions, then compute their averages and variability to demonstrate statistical inference in action.